Okay, so this is the third problem from the book IE1. A car starts moving rectilinearly first with an acceleration w is equal to 5 meters per second square. The initial velocity is equal to 0. Then uniformly and finally decelerating at the same rate w and comes to a stop. The total time of motion equals tau is equal to 25 seconds. The average velocity during that time is equal to 72 kilometers per hour. How long does the car move uniformly? So to help you visualize this problem, I have drawn the velocity versus time graph. So what this problem says is that the initial velocity is 0 and then the car accelerates at the rate w for some time. Let that time be, let us say that this time interval from here to here is t. Now we also know that it is decelerating at the same rate. So what we know is that this time to this time should also be equal to t, because it has taken time t to reach the velocity. Let us call this velocity v max, that is the maximum velocity it has reached. So it has taken time t to reach maximum velocity from 0 and it is decelerating at the same rate, so it should take same time to reach from the maximum velocity to 0. I hope this part is clear to you. Now we know that the total time from this point to this point is tau is equal to 25 seconds. So what is this time interval? This time interval is simply tau minus 2t. So let us say that this distance is s1, s2 and s3. That is, the car accelerates for time t and in that time t it has covered a distance s1. Then it moves with a constant velocity v max and it has covered s2 distance in time tau minus 2t, and then finally the car comes to rest from maximum velocity, and in that time interval, which is t, that distance is s3. Now s3 would be equal to s1, but let us now call this s3 for the moment. So let us form some equations based on the information that is given in the problem. Let us find out if we can find v max. What is v max? For this we can simply use the formula final velocity is equal to initial velocity plus at. That is, the initial velocity in this case is given to be 0, so this will cancel out, and a in our case is equal to w. So what we get is the final velocity v max is equal to w times t over here. This distance is covered in time t. So we get the expression for v max. Can we get the expression for s1, that is the distance? Again, using the formula, we will use the formula s is equal to ut plus half at square. Now we know that u is 0, the initial velocity is 0, so this term cancels out, and what we get is s1 is actually equal to s3 is equal to 1/2 times the acceleration, which is w in our case, times t square, because this interval here and this interval here is t. What is s2? Now for for the case of S2, the velocity is constant and the time is tau minus 2t. So the distance S2 is simply velocity times time, which is in our case Vmax times tau minus 2t, which is equal to Wt into tau minus 2t. So what is the total distance that we have covered? That is, I want to find what is the total distance that has been covered. Let us call this distance S. So the total distance that we have covered is actually equal to, total distance is S1 plus S2 plus S3 is equal to half times Wt square plus Wt into tau minus 2t plus half times Wt square. So from this we get the total distance to be equal to, this is Wt square plus this is Wt tau minus two Wt square, and this is equal to Wt tau minus Wt square. So we have an expression for total distance which is equal to Wt tau minus Wt square. Now the additional information that we have been given is the average velocity. Now average velocity is actually equal to the total distance by total time. So we know that average velocity is equal to total distance, which is S in our case, divided by total time, which is equal to tau in our case. So from here we can get one expression for S, which is equal to average velocity times tau. So now we have two equations for S. Equation number 1, let us call this equation number 1, and let us call this equation number 2. Now we can simply equate this equation to form a quadratic equation and solve the problem, and we will get our answer. But in this case I will try to express the answers in the terms of symbols that we have. This is just a convention, or you can say a practice. This is just customary, and in the final solution for the problem we will just replace the symbols with numbers to get the answer. So how we will proceed is, we'll just equate equation 1 and 2. So what we will get is Wt tau minus Wt square. This is actually equal to average velocity times tau. Now this is a quadratic equation. Quadratic equation is of the form Wt square minus Wt, let us write it like this, Wt square minus W tau times t plus bracket V times tau is equal to 0. So we can see the variable is t square, and the quadratic equation is of the form ax square plus bx plus c. That is, the if we say this is one coefficient, this is so this is the coefficient of t square. Over here is the coefficient of for t, and over here is the constant term. So we know the formula for the quadratic equation. So what we can say is t is equal to minus b, which is in our case w times tau, plus minus b square, which in our case is w square tau square, minus 4 a c. C is bracket v times t, divided by 2a, which is in our case 2w. Now we can write this equation as 2t is equal to, and we distribute this fraction, so we get tau plus minus, we take out w square t square outside this whole radical sign, so we get w tau divided by w, and what we are left inside is 1 minus 4 w bracket v times tau divided by w square tau square. This w cancels here, this w cancels with this w, and we are left with w in the denominator. This tau cancels one power here, and we are left with tau in the denominator. So 2t is equal to tau plus minus 1 minus 4 bracket v over w tau. Now tau minus 2t, which is what we are supposed to find in the question, that how long did the car travel with the uniform velocity. We simply subtract this from tau, that is tau, we have already found 2t, we simply subtract this expression from tau, we get minus plus tau into 1 minus 4 times bracket v times wt. Now because the time cannot be in negative, so we will ignore the minus sign and we will only consider the positive sign. So we can actually ignore this minus sign over here. So we can ignore this minus sign, and this is our answer finally. So this is the answer. Now we simply put the values in this. We know tau is equal to, we know that tau has been given to be 25 seconds. So tau is equal to 25 seconds. 1 minus 4. Now bracket v is actually equal to 72 kilometers per hour. We need to convert it into meters per second. So we just multiply this by 5 by 18 and we get 20 meters per second. This is very important because you should put the correct units, otherwise you will not get the right answer. This acceleration is 5 meters per second square, and this tau is again 25. So we get 4 times 5, 1 minus 16 by 25, which is actually equal to 25 into root of 9 by 25, and we get 25 into square root of 9 is 3, square root of 25 is 5, and we finally get our answers to be 15 seconds. So the car traveled with uniform velocity for 15 seconds.